General Protocol Spaces, Banking on Freedom.
Welcome to General Bull number 54 of N. We're going to be continuing. This is a third continuation of the topic of bringing the EXO project to life and showing what we've been working on, how far we've got, how we're seeing the problems that need to be solved, and so forth. This is based on this one that we're going to do is another walkthrough. So we're going to be walking through the third article that we have published on the EXO blog. So we'll link that in Twitter for you to follow along if you'd like.
Second.
And Jonathan, sorry. This is the third article, the second technical article that we have that's focused on the actual internal build and like how the templates are used and what is going on in at the technical level. Yes, sorry about that. So having said that, Jonathan, could you go ahead and get us started? Where are we going today?
I'm sorry, the last thing I heard was so.
I said so. Could you take us along with you? Let's get started and tell us where we're going.
You hear me?
Uname, are you able to hear me or am I cutting out?
I can hear you, both you and Jonathan, all right, but I don't think Jonathan is getting us.
Yeah, it seems he's not hearing. In the meantime, what we're going to talk about, if you go to stack.exo.cash and the blog, there's an article here called Vision to Reality 2, Managing State and Ownership. Stack.exo.cash/blog. I'll share that one right now while we're waiting for Jonathan to read something. All right. Posted the article if you'd like to look in the thread. What we did last time was we had walked through a very particular template in the EXO system. So we walked through what it looks like to do a very common transaction that pretty much the only transaction that happens more or less on chain today, which is the P2PKH. That's paid to public key hash, which is just paying to an address. Basically, what people think of when they say send me an address or sending money to an address. More or less, that's P2PKH. So we walked through how that works in the EXO stack, and there's a lot of things that go on. There's a lot of work that happens. There's the templates. There's the security issues. What was that? All right, good. All right, let me finish my quick intro. So yes, we walked through the P2PKH setup and how things work at the EXO level, like how they're actually working on in EXO or how they're going to work. Both, it's mixed in since we're working on it. So that was the kind of the simplest possible introduction to something that already happens on chain a lot, and then how that would happen with EXO. And more or less, it's a mixture of what wallets and their internal systems do today, but everything done in more or less a completely different new way. So end result, same thing. You get a standard send a transaction to an address, but the way that it's done is made so that it can expand into an incredibly larger space where app developers and users have safety and ease of use and cheap development, with everything, not only with the simplest of cases. So that's what we did last time. This time, we're going to get into state and ownership, which Jonathan is going to explain better than me. But basically, when you do all these things, when you do things with a normal wallet, it has to track all this data. And just like with the normal send to address, that's all a kind of a bespoke implementation. Everybody does it their own way. Everybody has their own standards, whatever, because it's very, very straightforward. And so there's not so much to think about when you do it. But when you expand out and now you allow any kind of transaction, any kind of contract, any kind of interactions between people, that old way of, just everyone having their own way to store state just doesn't work. And now you want to also be good user experience. You need to synchronize state between people who have the same wallet, etc. There's a lot of issues here. So that's what we're going to get into. Now, let's check in on Jonathan. Is the Jonathan in the room with us now? You name? Are you there? I'm all alone. This is wild.
I'm not hearing anything from him.
Hey.
Hey. Yeah, I'm back.
All right.
Jesus Christ. Maybe we should.
We really gotta get off of Twitter. Yeah, I think this is the end. We gotta migrate to something else. Twitter is so incredibly unreliable. So I was giving the introduction. Were you able to hear most of that? Some of it.
I think I missed like at least half of it while I was messing with rejoining.
Right. So the part that we're getting into today is one that sounds very boring, but it's really the central heart of difficulty. It's the difficult problem, or one of the most difficult problems to be solved in this expansion from, just doing send to address, and that's all your wallet knows how to do, and expanding from there into doing any kind of contract in a safe, reliable, easy to develop way. The expansion there is enormous. The amount of responsibility that your underlying infrastructure has to take on is huge.
Jonathan should be in now.
Yeah, I hope I am.
There he is.
Yay.
Right. Yeah, two different browsers down and a bunch of RTC and stun issues in the logs. So it's some network issue that Twitter isn't handling properly. Where were we?
All right. So I gave a quick intro to what we did last time with the P2PKH walkthrough, and how that leads to this really big, important problem, which is state management and determination of ownership, and those kind of concepts that until now we got for free, because the thing that we were doing was extremely simple and deterministic, HD wallets or single keys. But now we're going into a different space.
I wouldn't call it for free, simply because we either didn't do it in the first place, right? We just did send and receive and we assumed things, or we actually paid a fairly severe cost for it, which is let the apps handle the state for us.
That's right.
Like we're doing currently with Wallet Connect, and like most of the Web3 ecosystem seems to be doing. So yeah,
That's
it
right.
certainly has some cost to it.
The devil is in the details. So let's get into it. Where are we going today? What are you gonna walk through with the article?
So I had to close my browsers because I thought they were breaking things. I don't have the article up right now. So maybe you can like kind of guide this, because honestly, I'm not sure how long I'm gonna be allowed to kind of be on.
Be allowed to be on. Papa Musk is gonna shut you off once he realizes you got around the firewall. All right. Yes. So the beginning of it is just the explanation of state and ownership. Like, what does that mean? You were saying before, I said we got it for free, and you said, no, not really. But what is
Right.
this state that we're talking about? Like, first,
Yeah.
how about let's explain it in the P2PKH, in the normal context that everybody's
Sure.
aware of just sending to an address. Like, what is
Sure,
the
sure.
state that we're talking
So-
about here?
So when we're talking about the blockchain situation, we have a setup where we take some value and we put a lock on it, a locking script. And in order to unlock that value, in order to transfer it later or do something with it later, we need to provide an unlocking script that matches the original lock. This, for pay-to-public key hash, is what most people just think of as providing the signature. And to a large degree, that is true. But technically, under the hood, it actually is a little bit further than that. Like it's you not only provide a signature, you actually provide the entire unlocking script that, together with the locking script, ends up verifying that signature to validate that it's actually real. And so for regular wallets, the ones using pay-to-public key hash and existing like standard ways of doing things, they start off by having some assumptions, like some pre-known and deterministic patterns that they use to go from the keys that the wallet manages into creating these locking and unlocking scripts. And so if you're looking at it, then the state that you need in order to unlock a specific thing is actually two things. One is that secret, right? The thing that can be used to generate the signature, the keys. And the other is the information about how to structure and encode that locking script in such a way that the unlocking actually happens. And for pay-to-public key hash, it's something that, because we have done it the same way, and that way happens to be deterministic, we can get away with simply storing a single piece of data, the keys, or the seed, if we want to derive all the keys until we get to the point where we spend them. But this does not work with locking scripts that are more complicated. It only works when you have this deterministic nature and all the involved parties knows what protocol to follow. As soon as you have a locking script that uses more than one piece of data, for example, now you end up having more than one piece of data that you need to track. And regular wallets don't track this data at all. Instead, they are offloading that tracking to external applications today. So if you, for example, go to Cauldron, then you tell Cauldron, this is the address that I have, and then Cauldron does a bunch of lookups and work and things in the back end. And then they store metadata about what pools exist, and they're doing their own indexing services and whatnot. The same holds true for our products like AnyHedge and the BCH pool. We follow a similar pattern where the app helps you construct the requirements, and then the app itself has a database where we store all the metadata required in order to help you create those unlock scripts later. And so that is what we talk about when we talk about state, right? The things that are required in order to construct these unlocking situations.
Can I try John's version of that?
Sure.
All right. So just to have it in other words, so today we have the P2PKH that Jonathan is talking about, which is more or less the send to an address. And when your wallet today deals with that, there's two parts. One is you can get an address to be sent to, and the way to do that is a very standardized thing called, well, either using a single key and you just have one address, which is straightforward. You're always using that address, or you have the HD standard, and the HD standard is a way that everybody knows, given the starting point, what the next address will be, and the next address, and the next address, and so on. And so everyone can kind of synchronize by just checking with each other. Hey, what's going on that one? Oh yeah, what's going on this whole string of addresses? So it knows how to check that out, and it's all just kind of mixed up in current wallets because there's just really one way to do things. And so where this knowledge about what addresses you have and what money is on them is some mix of, my wallet keeps some kind of data, and so in my phone or on my computer, and it is able to track which addresses without necessarily looking them up every time, but it basically is looking them up all the time. So it knows how to do that because everybody's using the same standard, and everybody does it in a slightly different way. And some people store information and some don't. But as soon as you go to something like Cauldron or AnyHedge, there is no way for it anymore to follow this pattern of, oh, well, everybody knows how it works. You start here and the next address is this. It's not like that anymore at all. It doesn't work like that at all. When you make a contract, like an AnyHedge contract, or you enter a Cauldron liquidity pool, that's not something you can just say, oh, we can predict that address. It's just an address out of the blue that has no necessarily connecting information to it. And now you are participating in that in some way. In that state, current wallets today have absolutely no clue how to deal with that. They have no concept of it. And so you are fully trusting an app to ask you the right questions about who are you and what is your address or what is your key or something. And then also trusting the app to tell you, oh, this is how things are. This is what things look like. This is the money that you have. These are the contracts that you have. These are the liquidity pools that you are participating in. You are fully trusting the app to do all those things for you. And there's like some little tiny stars there where you technically could figure a lot of this out if you're a developer. But then what you'd be doing is building a whole app just like they did, except you would build it. So the state situation is moving into an area, like I was saying in the beginning, where the place that we're getting into is a place that current wallets have never stepped, have never walked, and have no concept of how to deal with it.
Can I try another even more dumbed down version? Yeah. Anyway, so imagine we are actually dealing with physical cash. And what a lot of people think of as, oh, I have this seed and I have this blockchain proof of work checking security. All of that basically actually just amounts to, the security features. Okay, I have a piece of cash. I have fancy little watermarks in it that I can hold up against the light. I have little microprints that are really difficult to fake. And if I am curious about this piece of cash, then I can check them, and I can tell people that confidently that this $5 piece of cash is the real deal. This $20. But that is not the whole thing at all. When we're talking about the state, there are some very basic assumptions that are just swept into the background that people don't even think about. Like, okay, yeah, you have this fancy security features, but you have this piece of rectangular paper or plastic, depending on which country you are, in the first place. And there's like a big letter, there's like a big number, 1, 5, 10, 20 on it. And there is this assumption that people can read these numbers. There is this assumption that, okay, you have a pocket where you can hold these pieces of papers that, and when you take these pieces of paper out of that pocket, they are probably cash, and there is a register to receive them in the shop. And when you want to pay, you go to the register in that particular shop you want to transact with, instead of tossing it into the mailbox next door. um that Those really basic things, like a lot of them are just state. You take a bundle of them out from your pocket, and without checking the watermark or anything, you can just see that, okay, I have five, I have one, and I have one, I have seven. I have $7 or €7, and the register can make some assumptions. Okay, this is how I make change. This is analogous to how P2P works. Everyone knows how they work already, and you have a bunch of state, and people know how to deal with them. But if you want to do something more complex, like, okay, I want to, instead of paying you cash, I want to make a deal with you. Okay, I want to take this nice little, I want to take this car, and I want to pay it in installments. Well, I can't exactly take out a huge box of cash from my pocket, so I am going to sign a contract with you. Here's where things get complicated, right? So a lot of people won't most people won't know how to deal with installments or you know um, car loans. So what actually happens is that you need a longer contract. Maybe it's like 50 pages long, or maybe less, maybe 20 pages. um there's a lot of details, and only a lawyer can interpret that. Okay, so what happens today is that, imagine that there's no other expert on this issue, and you go to a car dealership, you sign to buy a car, except that the dealership provides the lawyer, and technically you can read through the whole thing yourself, but nobody's gonna do that. And even if you do, you don't understand like half of it anyway, because it's all legalese. So you rely almost entirely on the car dealership to tell you what's going on, and how to how you're gonna pay, and what kind of recourse you have. And if they screw you, then you're gonna have a bad time. um so yeah, we're gonna change that um in some pretty significant ways. Sorry, back to you.
Nice, nice, nice. They are definitely not on your team. EXO is all about getting the knowledge, state, management, ownership, all of that onto your team. All right, Jonathan. Hope we didn't ruin your journey here.
I think like there's a concept in there that's actually fairly important, and that is the transition from like a direct transfer setup to let's do contracts, which in the legalese world is just papers and judges essentially, and in our case, the papers are the blockchain scripts, and the judges is the proof of work miners that just determines whether what actually happens. But all right, so we've covered kind of like what state is, but just knowing what the state is isn't really sufficient to do anything meaningful with it. So when we're talking about state in the context of EXO, we're actually talking about state management, not just state identification. And there are many, many different ways to look at what the EXO is going to be doing and how it's going to be involved in this. And let me start by saying that EXO in itself, like the engine that runs in order to execute everything, it actually doesn't really know much about state. Instead, it is a template that defines what state exists and how that state is intended to be used. So for example, if you have an NaHedge contract, there is a duration or a maturity timestamp on that contract. And EXO doesn't have a concept of time. EXO doesn't have a concept of a timestamp. It only knows that there are data and that data needs to be stored and managed according to the defined ways in the template. And so it is a template that tells you that when you fund a contract, you need to provide some variables in order to create a specific lock script. And then further, it also tells you where these variables need to be saved, essentially. So the model we are doing right now is that whenever you create an output on chain, then EXO is going to have metadata attached to that output. And whenever you spend that output, that metadata is going to be available in the context of creating the unlocking side of the script. So this means that you get to carry the state from one output to another. And it also means that there is a natural point where that state exists and is intended to exist.
And again, to go back to the P2PKH, to the standard addresses that people are used to, when Jonathan says that we're storing metadata and so forth, this is what I was saying before with today's wallets. They all do something similar. Hopefully, some of them don't. Like web wallets typically don't store any of this or very little of it. But with this, we're going to a place where it's all very standardized and everything fits in the same form. So now we have one way to deal with any possible transaction, or at least that's the goal. But there will be some edges that we have to work out eventually. But basically, any type of transaction you can do now, there's a standardized way that we're making to track that metadata and make sure that your wallet is aware of what you have done and what you're doing.
Yeah, maybe I should add a little bit more context about the state being carried through output and what that actually means. So imagine you're doing pay-to-public key hash and you're creating your first lock script because you want to receive some funds. In order to create that lock script, the
Wait,
key...
Jonathan, can I say something real quick? For
Sure.
the people who are listening, when Jonathan says lock script, anytime you put money into something on Bitcoin, you're putting it into a lock script, which just means what are the rules for this to be able to be spent. And the standard way that we do of sending to addresses, just that everybody is used to if you've used crypto ever, is literally a program. It's a little program. It's a little script that says, here's how to unlock this money. And it's very simple. It's, sign for it. And then you can do whatever you want. It's kind of the simplest possible, or the simplest reasonable possible way to spend money. So when you're sending to an address, you're literally sending to a little program. And that's what Jonathan's talking about with the lock scripts, is that we're going from the simplest program to a place where we can deal with much more interesting programs and rules around the money.
Exactly. So when you're making an address, you need to have a lock script that you can encode into that address. And to make that lock script, for pay-to-public key hash, one part of that lock script is the hash of a key. And so you need to have this key, but you need to have it not only when you make this lock script. You also need to have the same key available when you try to do the unlocking later. And so normally for wallets, they just store all the keys, right? Every key they generate, they just store it somewhere. And whenever you need a key, they just go look that key up. And that is an approach that works when you have this deterministic pattern. But in EXO, instead, we store a reference to that key, and then that reference we store on that output, not on chain. We're not storing the metadata on chain, but inside of our own internal state systems, we store a reference to how that key was made so that we can recreate the key when we need it later. And when you then come to the point where it's time to spend this pay-to-public key hash funds, since you are actively consuming the output, you're also removing the state from it in the state system. So you have a natural point where state can be forgotten or can be archived. So you don't have to have all the state available always. There are some drawbacks to this. For example, if you look at the BCH Guru application, they have a multi-step process where you start by making a secret guess, and then someone else makes their own guess about it, and then later on you pay out some kind of bet. And in this multi-step process, what you would do is that inside of the template, you would tell the first step, like, you need to keep this information available. And then in the second step, you forward that information to the next output. So you carry it across multiple steps. But eventually you reach a point where you reach end of life for that state when the bet actually pays out. Does that make sense?
It's beautiful.
All right, so we've established that state in the EXO system is tied to the outputs. Now, what happens if someone sends you something that EXO isn't expecting, right? So you have some tokens on some address and someone does an airdrop, and so you get some new funds. If we assume that EXO is only capable of handling the things that is well coordinated when all the information is available and when template have explicitly defined this is how you're supposed to do this action or that action, and this is something that, generally speaking, like, is unhandled. Like, this is an exception to the rule. So in EXO, we broke down the output definition and the locking script that the output definition uses into two separate parts. And then we said that if we ever get an output that we do not understand, but it uses this specific locking script, then this is how you should handle and manage that output. And this allows us to handle all the unhandled cases, all the airdrops, all the dustings, and all those situations where, for some reason, you have not been properly informed of what's going on, but you're still able to, for the most part, unlock and access your value. Of course, if your lock script is designed such that it simply can't access that value, for example, if you have an AnyHedge contract and someone sends a token to it, then you can't do anything with it. But that's not EXO's fault. That's simply like a matter of fact with regards to the locking script you're using.
Jonathan, let me ask. So the things that you're describing, for somebody who's technical and has worked on maybe wallets or contracts and so forth, any of those things, they may hear this. Like, I was just listening to it now and think, what's the big deal? What's the difficulty here? Why are these things that you're saying hard? They seem very obvious. Why are we saying that this is a difficult problem?
So the difficulty isn't that you can't do this in a bespoke manner. If you have a wallet and you want to add support for a specific application, for example, maybe you want to build Cauldron as an application inside of your wallet, then you can, of course, sit down and write down the rules in your application for how Cauldron behaves. Make a list of how to find those patterns for the pools and how to use them. But what ends up being done here is that you're doing something that is bespoke and usable only for your wallet. You can take a step back and you can write a library for it and try to make it more widely reusable. But then everyone who wants to use this library still needs to do some kind of bespoke implementation on their end in order to be able to support it. It also means that if you want to have more than one such applications, maybe there are competing DEXs and you want to support more than one of them, then you're going to have to do a bespoke implementation for each and every one of those DEXs. And not every one of them is going to do all the work to make a very convenient and easy to use library, for example. So the hard part is generalizing the problem such that we can provide a solution that lets a wallet go from I have no idea to okay, I can do this now. And to do so safely. Safely is a very important keyword here. Imagine
Exactly.
the large amount of like minor bugs that happens in the large amount of wallets that exist out there. If everyone is making their own bespoke implementations, then everyone gets their own bespoke bugs, right? And users jump back and forth and have bad experiences in a lot of places. But if you have a generalized system that is mature, tried, and proven, and they all share the same templates for how to implement specific use cases or features, then you get to a point where they either don't have bugs or the bugs they have are the same everywhere. And I think this is a really valuable thing. It also means that you get a compatibility situation where, for example, if you support Cauldron in one wallet and you're using that wallet a lot, and then you move your keys over to a different wallet that also supports Cauldron, it's not guaranteed that both wallets will see the same history, the same view, and the same everything, because they might have nuances that differ in their implementations. But if they're both using XO templates and they both import the Cauldron template, so they have the same template, then the patterns ends up being repeated and identical in both cases.
And I wanted to add something. It's not only that we're generalizing it, right? That XO will generalize it so that your wallet can understand all these things, which is important. But very critically, your wallet, which has the engine in it, which understands all these things, is now on your side. That's an incredibly important point. Now you have someone on your team who understands exactly what's going on and can show it to you in a way that you can understand, as opposed to just some technical blobs or trust me bro type setups. This
Absolutely.
is a huge point.
But that's not a result of the state management. That is a result of the change in orientation of trust and the way that we distribute like in templates and what the reputation and trust system around those templates are.
Well, in some ways it also is, right? Because now we know that when I have whatever my situation is, I'm involved in 15 contracts, I have this much money, I have this much money in a vault, whatever. This is my situation. I know that with the XO setup, I have all that data. It's on my side. I have some control over that, and I'm able to say where that goes. Whereas the current situation is you actually don't really have control over that. The apps or the counterparties that you're dealing with, which have the sophisticated bespoke software that he was talking about, they're the ones who know everything. You don't really know what's going on. Your team doesn't really know what's going on. So yeah, it's both. It's both.
Yeah, state management is absolutely a requirement in order to be able to move the trust away from dApps over back into your wallet. That's true.
All right. So the other should I move to the second part of the article, or would you like to say more on the state side?
Move ahead. We can take everything as it comes. It's fine.
All right. So there's another interesting part here, which is when you look at P2PKH, which what we've been using as a kind of an example, a counterpoint here for everything, which is just sending to addresses. So you're sending to addresses, to standard addresses, the ones that start with a Q. You're sending to these addresses, and when I receive money into one of these addresses, you don't even think about it. It's just incredibly obvious that it's not even worth saying that all of this is mine. This is my money now, to the degree that I'm able to keep my private keys secret. This is my money. But when you put money into a AnyHedge contract or a Cauldron liquidity pool or a car loan or whatever it is into one of these contracts that we can now deal with natively, how much of that money is mine? Like, what does it mean now? If my wallet is looking at this contract, this AnyHedge contract, and it says, well, there's your money, but it's not just your money, right? Now it's your money is there, and it's also mixed in with the counterparty's money, and it's also mixed in with some fees or whatever. How do I look at that? How do I explain this?
Yeah, this is a problem that is not trivial to resolve. Because if you're only relying on the technical information that the blockchain provides you, then as you said, you're going to be conflating the ownership side. You don't know whose data is whose, you don't know how much, and you don't have any expectations. Now, the reason I say that this isn't a trivial solution to solve is that there are actually many cases where it's either not possible to know, or the difficulty in getting to a point where you have a good understanding is not very straightforward. Take, for example, if you have a clear prediction market, like a future prediction market, where you have a binary outcome, where it can either be true or false, and you're betting some money on that something is going to happen. Now, someone else bets against you, like you each put maybe 1 BCH into a contract, and the contract governs how it's going to pay out in the future. But when you're looking at it, you can't with confidence say that, hey, this 1 BCH in here is mine. Because if you were, you would be telling user that they have a BCH here, and then when the future pans out, they may not have that BCH. But in other contexts, if you're looking at the BCH Pool app, for example, and you have these contracts, the NHEDGE contract, now the same situation exists here. You have put some funds into a contract with some expectations on it, and some counterparty has put funds in. We know that at any given time when you look at this, there is a current state where we can say that it's likely, like if nothing else changes, then this is the expected outcome. Because as the developers of the NHEDGE contract, we know how the contract itself behaves. With this information, it is possible to design user interfaces that actually do resolve the question of what is the expected ownership. But doing so in a wallet without having those specialized things is not something that has happened yet. So in XO, inside of the templates, we actually say that when you're looking at a specific output, in the definition of a specific output, we allow the template authors to add cache ASM evaluated code that resolves down to what that expectation is. And this allows you to answer the question like, what can I expect about ownership going forward and in this specific time, but also allows you to answer that question across any number of generic contracts, right? As long as the template provides this information, a wallet will then be capable of showing like, what is your breakdown? What is your net worth across all your different smart contracts you're working with? Today, you could actually build something like this as an app. You could have an app where you log in, for example, with Wallet Connect to disclose your address. And then the app could be looking at all the things in your history that you have done. And then it could try to coordinate and ask other services for a bunch of metadata. And in the end, it could potentially be possible for it to give you a pretty little graph or some pie chart or something like that. But you would still be trusting that app, right? Someone else will be telling you things, then you can't verify them. You can't know for sure what it is. But when you have the XO templates, your wallet will be able to produce this kind of information and to be able to provide these kind of overviews. And that, I think, is a significant step forward in terms of usability.
If I oversimplify, if I try to provide an oversimplified picture, you can think of a spectrum with two extremes. On one end, your wallet knows everything about your assets, which is relatively easy to do today, because you're just using simple addresses and send and receive. So on this end, your wallet knows everything about your money, and it says, this is your balance, period. Congratulations. And then on the other end of the spectrum, your wallet is just like, bro, I don't know anything. I don't understand any of this stuff. I don't know what's going on. But you've got money, or you don't even necessarily have money. You did some stuff with money at some points in the past. And these are all the contracts that you touched, and these are all the addresses that your money touched. And I'm really not sure what's happened since then. And so the wallet is unable to understand what happened to the money. And so these two ends of the spectrum, we're trying to land somewhere very close to the first one, right? Where your wallet knows as much as possible as it can about what you have done and where your money is and what your situation is. And like Jonathan said, with some contracts, you literally can't know until a future date because it's a random chance or it's a prediction market or something like that, where you either get the money or you don't get the money. How do you say what the balance is on that? That's an right. There's complications here, but there's a big difference between saying, well, you're in this contract and you might get the money or you might not. And a wallet maker can pretty easily come up with some reasonable way to present this, as opposed to the bad end of the spectrum, where it's like, well, you sent money to this contract, and first, I don't know what this contract is, and second, I don't even know if you're related to this money anymore. You might have been paying for something to a contract, and that money's gone because you just paid to some kind of specialized contract, or this might be a pool of like 10,000 BCH because it's a shared contract, like a liquidity pool. Is that yours? I don't know, man. Are you made part of it's yours? I don't know. Maybe you'll get some of it back. I'm not sure. So there's these two ends of the spectrum. There's a very ugly end, which is where we are in the current situation. Anytime you want to be involved with contracts, anything more than just sending and receiving addresses, modern wallets are just like, bro, I don't know. I'm not sure what's going on with your money anymore. Go ask them. And that's a very bad situation to be in. The place we're trying to get to is where the engine is able to understand to a great degree where all your money is, what it means for it to be your money, and then the wallet makers can decide how to present that to you and how to wrap that up in a way that is helpful.
Yeah, like John said earlier, we want this to end up in a situation where whatever wallet or app that you are running yourself, that one should be entirely on your side, and you should not need to trust any external parties. Of course, there is value in having external parties that can help you do things, but the trust situation should be, even if someone else helps you and even if someone else provides data, you should be able to provide the absolute truth in a human accessible way directly from your device without needing that trust. So yeah, let's go back to like the ownership side. So I said for every output, you have this property where you can say that like this participant that takes part in this output, this or that much of this is expected to belong to them. But it actually doesn't stop there, because there are more layers, there are more things you can look at. That currently we're operating under assumptions, and assumptions work out because we only use pay-to-public key hash. But for example, one of the other things is something technically spendable? And this is a situation where if you have only pay-to-public key hash, you can resolve this question by asking, do I have the key? As long as you have the key, then it is spendable. And for a regular wallet, that means essentially every output you have is spendable because you're only doing spendable outputs. But imagine now that you take one step further and you want to make sure that you don't re-spend funds faster than some certain rate. So you add a little bit of delay in your system, and that you now have a pay-to-public key hash that requires you to wait a week after you get a payment before you can spend the specific payment. Maybe this is for legal purposes. Maybe this is because you enjoy having more control over your funds, or maybe you have some reason for it. But once you have moved away from the fixed pay-to-public key hash to this pay-to-public key hash with a delay, something interesting happens. Each output now has more than one data point that determines whether they are spendable right now or not. Not only do you need the key, you also need to compare the current time. And so with the XO template, since the spending conditions are listed in the template, the engine can evaluate this technically without executing on it. And it can give you an answer for whether something is spendable or not. allowing you to take your balance and split your balance into like a pending balance that you might have later and a liquid balance that you do have now. Names, of course, for everything pending, and different wallets will interpret things slightly different. But this is something that this level of distinction, it doesn't really exist outside of XO at the moment.
It doesn't even come anywhere close to existing outside of XO.
Yeah. So I wanna jump in here and break up this fascinating dev talk by saying that I posted a comment on the current Twitter thing we are doing right now with a link to a transaction. And I'd like to say that to everyone's listening, we have been working a lot on XO in order to like figure out how we want to build it, like how we want to architect it, and what the requirement and design goals and whatnot is. We worked to some degree to get somewhere on that end, but then we changed our design, and we essentially ended up starting up from scratch again. And it has now been a month, 2 months, something like that, since we kind of decided which direction to go when it comes to the architecture. And the transaction that I linked here is the first transaction that our internal engine was able to produce that was accepted by the Bitcoin Cash network. It is a transaction that spends from and sends to simple pay-to-public key hash, so nothing impressive or to really talk up about. But it is being done by an engine that does not know what a lock script is, and that does not know a lot of those other assumptions that regular wallets would do. It merely followed the instructions inside of a template until it generated some piece of data, and it sent that piece of data on chain and got that piece of data accepted by the network.
So I know
Awesome.
that this is early days, but have you guys received any feedback from wallet developers?
We have
there's one example with Jeremy and Celine where I tried to, in my typical fashion, I try to approach it as, you know, this is going to be a lot of friction, and it's a huge change. Like, it's a real sea change in how to deal with your assets and how what a wallet means, and it's going to be a big switchover that's necessary. Like, there's a lot of aspects of this that are not backwards compatible and so forth. And I kind of presented it in a negative way, and he's like, whatever, we'll work it out. It's gonna be great. And I was like, okay, all right, that's good to hear. But yeah, that's a big part of why we're doing this in public, so that wallet developers, especially wallet developers, can come in and look at it and be like, oh, that's how you're doing things, and, you know, maybe share advice because they have experience making wallets, or give us some ideas that we didn't think of, or at least just follow along and see where we're going, and they can kind of start to imagine how this is going to work with their wallet and how they might use it and so forth. So I was expecting to receive a lot of not very happy feedback, you know, disgruntled type stuff, or, you know, doubt. But instead, so far, I've only heard, oh, this is going to be great. But yeah, I'm not sure how many people have really got into the details yet. But these articles are there, and they really do get into the details. So it's right there.
I don't think the vast amount of wallet developers have done any deep digging in this, and we are definitely going to hit edge cases, and it's going to be an uphill battle to get people to adopt this kind of system. I will say that among the team that is working on this on our end, we have at least 3 people from 3 different wallet implementations. People have made wallets before. So we have some amount of experience and wisdom when it comes to like the things that wallets usually encounter. But the real selling point of this is going to end up building the actual first templates and apps and demonstrate that you can do things with this that you simply can't do without. And then the idea is that users are going to ask their own wallet developers, could you implement this? And they're going to look at it and say like, no, this is black magic. We can't do this. And then eventually they will, you know, get around to and realize that, hey, actually, what you need is to support XO standardized templates in your system, and if you do, you get all of these things for free.
And not only do you get it for free, but our prediction is, because we wouldn't be doing this otherwise, is that once people start using it, once developers, wallet developers, app developers start using it, it'll be an economic forcing function. It'll be so much easier to build apps. It'll be so much safer because you don't have to worry about a lot of the details. And so much cheaper because you can hire somebody who doesn't need to know all these things to build financial apps. It's going to be so incentivized that people are just going to want to use it, is what we predict. And so we'll see how that goes, but I'm looking forward to it. Tim, did that answer your question? Have you had a look at it yet?
Yeah, I mean, I've only looked at it a little bit, but yeah, it sounds like you guys are on a really good path. So I'm encouraged and excited.
That's great.
Great
And
to hear.
I do hope everybody who's listening will go and have a look at these blog articles, because you know how it is. You hear something at a high level and you're like, okay, that sounds cool. And then, well, at least for me, and then I look at the details of it and I'm like, wow, but have you thought about this? Have you thought about that? What about this situation? It'll break in this case. And so if there's anybody out there who goes through these articles and reads it and has those reactions, like, come talk to us, tell us about it. You can come in the General Protocols Discord, or there's actually I think there's an XO, it's not Discord, Telegram. There's the General Protocols Telegram, or I think there's an XO Telegram. Yeah, just tell us about it. Tell us about it on Twitter or whatever, because that's what we're looking for. We'd really like to engage and hear what BCH developers think about it.
Yeah, and if you want to speak face to face, come to Blitz next year, and I'll be there, and you can tell me all about it.
Yes, and by that time, who knows where we'll be. We've already, like Jonathan said, in a month or two, we've got XO building transactions based on templates and the rudimentary engine. So I'm looking forward to making great progress here. And for anybody who's made wallets or any kind of complex system, you know that there's the core idea of a thing, and then there's all of the details that are needed to make it actually work in practice. And those are going to take a very long time to get right. But we're definitely on the way.
Yeah, I'll just mention the elephant in the room, like the largest part of this, and that is that when you are on a state-based system, loss of state equals loss of funds, right? If you make your own little NIH contract and then you forget all the parameters, not only can you no longer find your money on chain because you can't reconstruct the lock script to get to the address to look it up, but you also can't construct the unlocking script required in order to actually spend the funds later. And so, yeah, loss of state is super, super dangerous. And so we are working on setting up state synchronization services that can be used together with cloud backups and on-device backups to achieve, to get away from potential single point of failures, and also to build those systems in a methodology that provides for the data to be encrypted so that the state sync server doesn't actually have the data. It only has encrypted blobs associated with entities, and entities can then request this data. And in a way that allows wallets to do something that wallets are not doing today, that is reverse chronological discovery, so that rather than starting like from the very beginning of the blockchain and working their way up to today in order to get a final outcome, we're building the system so that they can start from today and that they can backfill history over time, allowing you to be able to take actions at the soonest possible point in time after you get started, rather than having to, go from the beginning.
Go back to the beginning of time and recreate all of history. Yes. And I would also like to add, so this issue that Jonathan said, that's a extremely dangerous situation, right? Because you have to have this state. This isn't optional at all. You have to know this information to make sure that you can control your money. And yeah, so that you can control your money and not lose your money. However, having said that, it's really important to note that unless you're going to stick to send and receive forever and you're never going to do anything more and never participate in the larger economy of P2P electronic cash like loans and financial products and vaults and um, recurring payment setups and who knows what else is going to appear. All kinds of things will appear. Identity, um, tickets, etc.
Tokenization
If you
process.
don't, if you're not going to participate in any of that stuff, then fine. You work with the way wallets work today, and it's relatively safer because of the deterministic nature of reproducing all these addresses. Relatively safer, but
I gotta jump in, John. It's largely irrelevant. If you look at the payment network that exists out there, the ones that are actually successful, we're talking Visa and MasterCard and the banking systems, the vast majority of payments are recurring payments. People who pay rent, people who pay gym membership cards, people who pay bus transit cards, people who like recurring payments is the game, and you need to get there if you want to capture significant market share on
yes,
on the cash system. And so whatever wallet you're talking about is it's just not interesting anymore, right? Let's move forward.
it's true. It's true. But let me finish my Steelman. So let's say it even was interesting, like just simple send and receive was interesting. Let's assert that just for a Steelman. Then you kind of have a thing where today it's somewhat safer, but you cannot participate in the rest of the world. And like Jonathan said, in the 99% of everything that actually goes on. So if you move into that world of participating in even slightly more complicated setups, like recurring payments, now in today's world, you're in the place where you completely depend on the app for all that state. And so with the XO setup, you can also let apps have that state and they keep it, and maybe they have a backup or they're able to use it if you want them to, but you can also keep it yourself. So you're very strictly in a better position than today. Today, you have no choice but to trust apps and third parties to tell you what's going on. With the XO world, you can also do that, but you can also at the same time, or choose one or the other, decide to keep it yourself and you manage your own state. So we're strictly going to a better place with XO as long as you assume, like Jonathan said, we're actually doing anything interesting. All right.
All right. So
I
what does
think
that leave us
we
in the context of today's topic of managing state and ownership?
I think we've actually covered the really juicy parts of this article, and for the technically inclined, you should absolutely go have a look at it. And it gets into even further details of how the actual templates work and where the state is and so forth. And we might get into that in another space. But I think this is probably a good point for us to wrap up here. Actually, did you want to cover any additional points, Jonathan, or you name?
No, I think
No,
it's pretty good, and we've been going an hour, so this is usually where we wrap up anyway.
Yeah. All right. Tim, did you have any? I really appreciate you joining us, Tim, and asking questions. Did you have anything you wanted to ask about before we wrap up?
Not this time, no, but it's fascinating, and I definitely want to look at these articles. And yeah, I'm really excited where you guys are going with this.
Okay. Thank you very much. All right, then. We will wrap up General Bull 54, Managing State and Ownership in XO. And please go read the articles on stack.xo.cash. Have a look at those articles, see what you think, give us some feedback, tell us what we're doing wrong, tell us what we're doing right, and we will keep moving and get into this better place for Bitcoin Cash and P2P electronic cash for the world. All right, take care, everyone.